questions on the floor for our speakers for the late morning session? Must be some questions. Sorry, Lynn on the way.
It's Lynn on the centre. Steve, actually, you were talking about going out to people who actually go out and collect the data from various sources. I was wondering if one of those sources was from the evacuation shelters.
Evacuation shelters?
Yeah, because I was thinking that seems to be a fairly ideal place to actually collect data, because you've got essentially a captive audience. They're going to be suffering for a while.
Yeah.
They can tell you what time they arrive, because it's only just happened. They can tell you their household members who you've come with, how they've got there.
Yeah. I mean, so the two parts to that was when we went over to Roxburgh, we actually attended. Some of our people were at the assembly point, and so it was precisely for that reason. It was that talking, experiencing what that was like, and then what happened next. So in this event, there was a debrief, and there was a lot of back and forth in terms of the experiences of people and the emergency responders. In terms of the post-incident data collection, sorry, I'm standing up, I've got a bad back. In terms of the post-incident data collection, we asked the people that went into the field where they went, who they talked to, what networks did they engage with in order to get access, where could they go. So I think some of that did touch on that. Were they able to get into those locations? Typically, they had access after the event, and so it was sort of null and void. But yeah, ideally, that would be a key resource if you could get access to that for sure.
Questions?
Actually, there are two for Anand. During mass evacuation, people can be exposed to terrorism attacks in case there is any imminent threat. So how shall the web exodus, how shall it account for that? And then also, how do you account for the actual decision-making time within the person himself before deciding to evacuate the building?
So I haven't worked much on the terrorist and building evacuation, but for wildfires we have surveys which has been conducted to determine what the mobilization time, as Sandra spoke about. So it takes into account so we conduct surveys to determine what things people collect before they evacuate, and how the notification process has an influence on their response times. Things like that. But there's been other projects that we looked at terrorism.
So just following on from that, from Sandra's presentation this morning, from her work and other people's similar work, we're looking at how long does it take people to respond and to make decisions as to whether to stay or go. So the model doesn't predict that, and I don't think any model can actually predict that. I don't think we know nearly enough to have a robust predictive model. But we have empirical models based on the data that have been collected, and that's what is imposed on the exit simulation. And as far as the other question about the terrorist case, the example that you saw on the evacuation of the Canary Wharf Peninsula, which actually has 150,000 people, not 15,000, but 150,000 agents, that's a simulation of a terrorist attack on the peninsula. And so the people are reacting to different calls to evacuate the different buildings. The whole area had to be cleared. And one of the things we were looking at there was which roads do you maintain for vehicles coming in to allow the 150,000 people to get out, but which roads do you allow the emergency vehicles to come in to tackle the emergency situation. So how we manage the simulation really depends on the nature of the hazard. If the hazard is a natural hazard or a man-made terrorist type hazard, that will influence how we set up the simulation and which parts we start to evacuate. Part of what we were looking at in that Greenwich Peninsula case is which building should you evacuate first to maximise or minimise the evacuation time, given that all these people are coming out and mixing in the communal areas there. Which building would be more appropriate to evacuate first, if you can control it, so that you minimise the congestion and maximise minimise the time to clear that area. So that's one of the ways we were using the model to try and find a good strategy for how you would handle a terror situation in that situation. More questions? Yes, Stefan.
A question to all the speakers. Which is, in your experience, the attitude of the local administration towards the efforts you're doing to improve the emergency planning and also management? In other words, I think that in Sweden, if I understood well, it's something that has been asked by the administration. But in the other cases, what do you think about future developments? Do you think that it's possible in the near future to application of the research results in the common practice of safety planning and so on?
So I can start if you want to. I mean, I think it's very dependent on the fire safety culture of different countries. So in Sweden, it has a long-standing history of fire safety engineering. So they're much more open and familiar, I think, with modelling and more accepting of an engineered response and the validity of potentially modelled output. From my experience in North America, I think there's an additional stage, which is to attempt to convince in the value of modelled output because of certainly in the US, in a more prescriptive approach to fire safety. And so I think there's a bigger divorce, if you like, from fire safety. And if there's anyone from North America, they can correct me, but the fire safety community and the wildfire communities are slightly more divorced because they've not had that crossover to the same degree. So there's an element of convincing people to make use of modelling, and then there's the next stage, which is demonstrating the value of modelling in their particular situation. I would also say that cost is a big issue. That's always the case. The element of funding that's available is going to drive whether someone wants to use your work or not. There's very few resources in this.
In my experience, well, it's difficult, but one of the good things I think about the GeoSafe project is that it have put in contact researchers with practitioners. So in Spain, I feel, for example, our work with the practitioners in Spain has made a feeling that we can work together. Some things we can speak the same language. So I think it has been important. There's still some way to go, but I think it has been an important thing to know that we can share a common language and we can help each other to improve. Yeah.
What we during David's interviews with end users, we found that most of the end users, especially when it comes to evacuation simulation tools, they're still a little bit skeptical about using it for real-time purposes. However, in Australia, the authorities are more accepting of late. So there was another evacuation simulation tool, which was being used by authorities, but it's still not being as widely used as, for example, the fire simulation tools are more widely accepted, and the authorities in Australia and probably other countries as well, they utilize fire simulation tools to estimate the amount of time it requires to evacuate an area. But then when it comes to evacuation simulation tools, I think it's probably a little bit more futuristic for them. But then CMBVF is very accepting of evacuation modeling. So that's a.
I think part of the problem is, as Anand has hinted at, is that a lot of the authorities don't understand what evacuation modeling capabilities are at the moment. They don't understand what you can do with evacuation models. They're still in a state of development, sure, but there are applications that they could be useful in, certainly for planning. And I think one of the areas that we're very keen on, we're pursuing as part of GeoSafe, but also other projects, is how we can use these tools for training the community even if the authorities mightn't use them in planning, but you can use the tools to inform and train the community as to why a decision to go or stay needs to be made quite early, by demonstrating, by simulating their own local community and showing them the ramifications of making that decision late, can educate the local community. And that's possibly one way of getting the local authorities more interested, is maybe not for planning or for real-time applications, which is perhaps a little bit off still, but certainly for training the local community so that they can understand it. And with visualizations like this, and making it local so that it's not some artificial, it's not some other town, it's my town, and I can see my house, my street, and my goodness, you mean if I didn't leave in 20 minutes, the road's going to be blocked by the fire and I'm not going to be able to get out of it, really? So I think that is one way of getting it more widely used, the public training aspect, and tailoring it to the local communities.
And another my experience, not in fires, but in other disasters, they use in evaluation. After something has happened,
Yeah.
then to use the modeling for evaluating what we have done and what we could have done. I have been local authorities using it for evaluation. I think this is a start.
Yeah.
Yes.
So my question is probably more for María, Teresa, and Alain, just because their presentations were adopted strong mathematical approaches, and one of the objectives of the Joseph project, as well as other European unions, is to foster the engagement of the users in order to develop some technological solutions to new knowledge that can be applied. So in your case, if you're having some strong mathematical approaches, I wonder the extent to which the end users find some practical applicability to your models, and whether or not you have a plan to guarantee that your models will have practical applicability once development has finished.
Yeah, I understand. It's more or less the same question, just as before. That means the gap between models, eventually strong, what we call strong mathematical model, and the applicability and the interest of the decider and the people on the ground. Here, in many cases, for instance, in industrial process management, you have a strong incentive, which is economics, to make money, and the process are repeating themselves, everyday process. That means you can easily, well, not so easily, but at some times you may convince, you may try to interact with deciders and convince them through experiment, through some experiment, that you may bring them something. Sometimes you can, sometimes you cannot, but experience shows that many times you bring something. In this case, it's a little bit different because things are very incidental. Wildfire or disaster that don't happen so often. They are handled on the basis of main criteria are not economics, they are about safety, and this makes the psychological relationship different. And so it's not, and there is a strong gap between people on the ground, their culture, and for instance, in industry, you have engineers, and most engineers come from people from master degree in science and computing, many things. Here you have really a big gap between people in scientific communities and people on the ground and public authorities. So it's not very easy to communicate, even in the case of GeoSafe project. For me, it was very interesting. For people in collapse and in rest, it was very interesting. But we could see that communication was not so easy. When we were in Australia, in some way, there were not so many people in front of us, and we could discuss during 1-2 hours, so we have some hints about the way people were proceeding, but there was not a so strong interaction. My personal feeling is that introducing some model, some decisional models, some decisional computing tools into the process, to either simulation, large simulation software, or online in real time deciding the controlling device, could bring something. But convincing and going until the end inside this process is not so easy, because things don't happen so often. So making the proof is not so easy, and it requires a lot of effort. You are not going to spend a lot of effort if there is not a demand in front of you. So it's a good question, because it was very interesting for us to think about those small good decisional rules when this. But we clearly felt that one of the challenges was to fill the gap between models, computing device, and real situation and real decision makers.
Okay.
Very, very fast. Yes, I think, yeah, of course there's a gap, but I think first, basic and strong mathematical investigation has to be done, research has to be done. So part of it, some moment would go to a computer system that can be used, that's once. So if you don't work here, you don't get the basic elements to get here and to go there. Then the second thing is, I was telling you, we have a good experience in the use of some of our models, not for real-time situations or anything, but for evaluations. For example, we have, it's not a fire situation, but we have a very good experience with, after the earthquake in Chile, they were using this, some of these, our mathematical models, to evaluate how they responded to the emergency, how the model told them to learn. So I think that's a first step, and that's important. Step 2.
I mean, I think it's vital to get champions within organisations. So you get someone to have using a model inside an organisation. They use it, they get used to the tool being on their desk, they talk to their colleagues, they talk to their bosses, and then if that tool is then removed, the gap is then clear. The value of these tools, and actually the predictions of these tools, is then self-evident because you've lost information. I think it's harder as an external party to say, to give a presentation, say this is what you could do. They almost need to have access to it and then use it, demonstrate the value inside the organisation, and then it's so clear. I mean, some of the applications here are so clear to us, but inside an organisation where somebody's saying, so we're going to spend time and money training someone on this resource, as opposed to buying a new set of other devices, kit. But if they can see it themselves, then it's a much easier debate to get that model used inside that particular organisation. Then once you've got one organisation using it, then it's the benchmark, and then others need to keep up.
I think I'll take Chair's prerogative and ask the final question for this session, and to Maria, Teresa, and to Alain. What I wasn't clear on in the presentations is I think it's each of the cases you're looking at are ideal situations, because not everyone, as we've seen, not everyone reacts at the same time. So you're having regions, you're saying they're all reacting at this time, and that just doesn't happen. There's a long range of times for even people in a region, even neighbours, to react. So that's the first problem I've got. Some of those nodes they're not going to react at 30 time units. They're going to react between 18 time units and probably 200 time units is probably going to be the reaction time. And secondly, assumptions about the road networks. How do you take into account existing traffic and the fact that not all the vehicles are going to be travelling at the same speed? You identified an ideal speed or a maximum speed, but vehicles aren't going to be travelling at the same speed. And also the complicating factor of the existing traffic. So can you comment on that, how your models take that?
Okay, now in our case, to the first question, we are modeling that people are not reacting at the same time. Right now, we are doing it estimating the probability distribution on how people will make the call saying I need to be evacuated. We could do it in a stochastic model to just taking some different scenarios. Right now we are using this probability distribution, so people will be appearing at different stages. About the road congestion, we are not considering road congestion because we are supposing this is early evacuation, but what we have done right now is to reduce the mean speed to a rate. The mean speed of each road by a rate, but we are using helicopters for the most urgent situations. So that the idea is the early evacuation, the vulnerable people should be evacuated before the rest of the population.
Yeah.
This is not always been possible to do so because some people will be asking for help later, but we are assuming the most people will be evacuated earlier, and then the other ones either by helicopter or if it is by road, we are reducing the speed by a rate. That's it. No, that's a gross approximation. Yeah.
In our case, we start from the point of view that we have to deal with highly monitored evacuation process. That means a situation which are requiring high support from local authority, monitoring authorities. That means not self-made, the converse of self-made evacuation process. So a situation in which people were in some way under, not strongly supervised, but in some way supervised. And we start from point of view that decision could help. We were aiming at producing simple decisions. That means we're aiming only at producing a priori, that means according to the process corresponding to hypothesis to some scenario. We wanted to produce roads. That means indication for the people which roads they have to follow. And this was one part of the job, and I didn't talk a lot about it. And next, during the jobs, during the evacuation process itself, depending on the context, we wanted to produce priority rules. That means 4 people were monitoring the evacuation process in some way, which had the priority on which kind of population, which kind of origin, where to put the focus. Next, we were clearly aware that all those things that have to happen inside a kind of stochastic process with kind of disorder. And but the idea is that in order to help put order into disorder, we had to make up some simple rules, which were priority rules. And in order to make up those rules, we didn't need such an accurate model. We didn't need exactly to represent. When we talk about a rate is not the base ideal rate. It is a likely evacuation rate in average for a given population, taken into account the start. But the idea is that even if this rate, this average